We are now starting the questions concerned with the topic of momentum for AS level for M1. The question statement is small spheres smooth A and B are of equal radius of masses 4 kg and 2 kg respectively lie on the smooth horizontal plane. Initially B is at rest and A is moving towards B with a speed of 10 meters per second. After the spheres collide, A continues to move with the same speed but the half of the speed of B. Find the speed of the B after the collision. So let's say these are the two particles A and that is the particle B. The mass of this particle is 4 kg and the mass of this particle is 2 kg. A is moving with the speed of 10 meters per second, whereas B, B particle is at rest. Then B particle is going to move with the speed of half of that speed. So if V2 is equal to V, let's suppose, then here V1 will be half of V because it is moving with the half of the speed of the particle B there. Now, according to the law of conservation of momentum before collision is equal to momentum after collision. And the emission will be equal to M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. If you put the values into this equation, M1 is of mass 4 kg, speed of that particle is 10, M2 is equal to 2 kg, it is at the rest, that thing is equal to M1 is equal to 4 into the speed of that particle is half V plus M2 is equal to 2 kg and the speed of that particle is V. So this is equal to 40 and that thing is equal to 4V. So V is equal to 10. So we know that the speed of the particle V there is 10 meters per second and the speed of the particle A is half of V and that is equal to 5 meters per second. So this is the first part of this question here. Now we are going to find out the second part. A third smooth sphere C of mass 1 kg with the same radius and the center as A and B is at rest on the plane. B now collides with C. After this collision, B continues to move in the same direction but with one third of the speed of C. Show that there is another collision between A and B there. Hello, what's wrong? अच्छा, चलो मैं 2 मिनट के बाद आपको मैसेज करता हूँ। Now, a third part. See, A and B coalesces during this collision. Find the total loss of kinetic energy in the system due to these three collisions. So, A and B, they are going to collide. That means what their masses will be collected together. Coalescence means what their masses will be collected together. So, third part is loss in kinetic energy. This thing we are going to calculate. But we know that kinetic energy is equal to half mv square. So, kinetic energy of the whole system initially, before it is not moving, when A is moving with the speed of 6 meters per second square. So, it will be equal to half into 4 into 10 square plus particle B is at rest and particle C is at rest. So, this will be equal to 200 joules. But we are going to find out the kinetic energy for the final. But for the final, we know that A and B, they are going to be coalesced with each other and their masses will become together equal to 6 kg. So mass of A plus mass of B is equal to 6 kg. And we know one thing, that the particles are going to be collided with the particle C there. So let's have to calculate the velocity of particle A and B when they have coalesced with respect to that part. So according to this law of conservation of momentum, momentum before collision is equal to momentum after collision. So for this particle A, mass of that particle is 4 into the speed of that particle is 5 plus mass of the particle B is 2 and the speed of that particle is equal to 4, which is equal to their masses, so that will be equal to 4 plus 2 is 6 into, let's say the speed of that thing is V. So it should be equal to 20 plus 8 is equal to 6V, or V is equal to 28 over 6, and that will be equal to 14 over 3 meters per second. So they are coalesces when the speed of that particle together is 14 over 3. Now we are going to use it for this final. So it should be equal to half into mass of this particle is 6 into 14 over 3 whole square plus momentum of this particle c is equal to half mass of that particle is 1 and the speed of that particle is equal to 12 and that is equal to whole square. Because after the fusion they are coalesced, B is going to coalesce with the C particle there. So this will be equal to whole amount is 412 over 3. So loss is in Ke is equal to 200 minus 412 over 3 and that final value is equal to 188 over 3 joules. So this is the energy lost for the three fusions between A, B and C there.